Hi everyone, my name is Mahendra. Welcome to my channel. Today I would like to explain about sign conventions for lenses. There are three sign conventions for lenses. First one is all the distances must be measured from the optic center or pole. Any distance, either it is object distance, image distance, focal length or radius of curvature. Anything must be measured from the optic center. This is the first sign convention. Second one is the distances which are measured in the direction of incident light, those are taken positive. It means the incident light direction and the measurement direction is same. In that case, we take positive sign. And if the distances which are measured opposite to the incident light, in that case we take negative sign. This is the second sign conventions. Third one, height of the object or height of the image, if it is measured above the principal axis, those height will be taken as positive. Or height of the object or image measured below the principal axis, those heights are taken as negative. These are the three sign conventions we have to follow. Now let us see how these are applicable for lenses. First, here we are taking biconvex lens. While doing numericals, we have to substitute the values object distance, image distance, and object distance is indicated with the letter U, image distance V, focal length, radius of curvature R1 and radius of curvature R2. So these are the terms which we use while doing numericals or when you are substituting in the lens maker's formula. First we see for biconvex lens, how will be the sign conventions for these terms we will see now. First, object distance U. Now this is the object, here is the object, and the direction of the incident light, once you observe, it is moving from left to right. And the measurement, we have to measure the object distance according to the first rule. All the distances must be measured from the optic center. From this point we have to start measuring. If we observe here, the direction of the incident light is towards right and the direction of the measurement is towards left. It means the direction of the measurement is opposite to the incident light. In that case, we take object distance for this convex lens as negative. Minus sign we will take. Suppose the object is at 30 centimeters. We will take a minus 30 while doing the numerical. Next, image distance. When the object is beyond C, see the direction of incident light, it is always towards right, and the image is found here between F1 and C1. We have to start measuring from optic center only according to the first rule. All the distances must be measured from the pole. Now you see here the direction of the measurement from O to I means image, it is towards right. The incident light direction also towards right. Both are in same direction. In that case, the distance we have to consider as positive. So here image distance is positive in this case. But biconvex lens also forms virtual image. So in that case, how will be taken the image distance once we will see. Now the object is between optic center and F2 focus. The direction of incident light towards right only. Here we can see the incident light direction towards right. In this case, the image is formed behind the mirror. Here the image is formed. Now we have to start measuring the image distance from O. O to I towards the left side. So the direction of the incident light is opposite to the incident light. So in this case we take as image distance negative. So here you have to understand that when there is a real image is formed, in that case the image distance is positive. When there is a virtual image is formed, in that case the image distance is negative. Next term, focal length. Now the incident direction towards right and focal length O to F1, it is also towards right only. So in this case the focal length is taken as positive because both are in same direction towards right only. Next, radius of curvature, it means O to C1. This is incident light and this is the direction of the measurement O to C1. Both are in same direction, so we have to take the positive sign. R1 is positive. Next, radius of curvature R2. It means O to C2. And here you can take as the incident light towards right and the measurement towards left. So here we have to take the negative sign. So radius of curvature is negative. R2 is negative. Whenever R2 is negative, if we take F2, F2 also will be negative. Okay. Next, sign conventions for biconcave lens. So here is the object. The incident light is towards right and we have to start measuring from optic center to the object. It means towards left. So incident light and measurement are opposite. We have to take negative sign. So you have to understand that for any lens, whether it may be convex lens or concave lens, object distance is negative. Next, image distance. What sign will it come? You see. Now, object distance is negative and afterwards image distance for this biconcave lens. Wherever we place the object in front of the biconcave lens, it always forms virtual, erect, diminished image. And the direction of the incident light towards right and direction of the measurement towards left. So both are opposite. For this biconcave lens, we have to take image distance negative. Biconcave lens always forms virtual image. So we have to remember that image distance for biconcave lens is always negative. Next term, focal length. See here, focal length for that focal length, incident line towards right and O to F1, it is towards left. So again opposite, we need to take negative sign. And radius of curvature, it means the distance between O to C1, optic center to C1, direction of measurement towards left but incident light direction is towards right. So in this case the radius of curvature R1 is negative. Next, radius of curvature R2 for this biconcave lens, incident light see that right side direction and O to C2 is known as radius of curvature R2 and both are in same direction, so we have to take here positive sign. So these are the sign conventions we have to follow while doing a numerical. Let us do one numerical based on these sign conventions. Question: What is the focal length of double concave lens kept in air with two spherical surfaces of radius of curvature R1 30 centimeters, R2 60 centimeter? Take refractive index of lens as n is equal to 1.5. Solution. First of all, we have to observe what type of lens it is. It is a double concave lens. For that double concave lens, what are the sign conventions R1 and R2? Let us see once in the table. Biconcave lens, R1 is negative and R2 is positive. So we have to write R1 is negative minus 30 centimeter and R2 is positive plus 60 centimeters. Refractive index value is 1.5. Using lens maker's formula, 1 by f is equal n minus 1 into 1 by R1 minus 1 by R2. Now substituting the values in this equation, 1 by f is equal, n value is 1.5 and minus 1, 1 by R1 value is minus 30, R1 value minus 30, substituting in this equation, minus 1 by R2 value 60. Then 1 by f is equal, 1.5 minus 1 value is 0.5 and this minus is here for denominator, giving to the numerator minus 1 by 30 minus 1 by 60. Finding the LCM of 30 and 60, it will be 60 and minus 2 minus 1. 1 by f is equal, 0.5, it is a decimal, can be written as fraction 5 by 10 and minus 2 minus 1 value is minus 3 by 60. One by f is equal 5 by 10 minus 3 by 60. After multiplying 5 3s are 15 and 10 into 60, 600. And 15 ones are 15 40s are. So 1 by f is equal to minus 1 by 40. Reciprocal of 1 by f is equal, 1 by f is f is equal to minus 40 centimeters. This is the focal length of biconcave lens. Thanks for watching this video.